Welcome back. So in the previous session we looked at the traditional grid method, and I hope that you were able to practice it. Now I'm going to teach you how to do the Napiers grid. I prefer using the Napiers grid because it misses out those middle steps. So it's a bit faster, which will save you time in the exam, and also there's less things that go wrong. However, I would stress that the important part of Napiers grid is making sure that you set it up properly. Otherwise it's going to give you a headache further down the line. So what I want to do is I want to prove how effective it is by using a bigger number. So let's try 372 times 489. So these are bigger than the numbers that we work with in that traditional grid method, but I'm hoping that things will move a little bit faster here. So what we do is we start off by just writing out that sum again, but we just kind of go off at a joint angle. So we go 372 times 489. Let's construct that grid around this. And I've run out of space at the bottom. Never mind. Okay, so what we do here is we have a grid. Now the way that Napiers grid works is we have to add something special. And what we do is we do a diagonal line that starts at the top right and ends at the bottom left of each corner. Just like that. This is what I was saying, where it's very important in this method that we set up properly. Now you can see that these lines are all over the place because I didn't use a ruler, so make sure that you do use a ruler and keep your work nice and neat. Okay, so now that this is all set up, we can start doing a little bit of multiplication. The great thing with this method is all that you need to do to use this method effectively is just learn the first 10 times tables. 2 times 4, well that's 8. So what we do is we put a 0 there and an 8 there. Now this top left corner represents your tens. This bottom right corner represents your units. No tens but 8 units. 2 times 8, well that's 16. Which means that we have 1 10 and 6 units. 2 times 9, that's 18. 7 times 4, that's 28. 7 times 8, 56. 3 times 4 is 12. 3 times 8 is 24. 3 times 9 is 27. And 7 times 9 is 63. Don't worry, you don't have to be very fast with your times tables. I'm a maths teacher, I do this all the time. But just make sure that you do get them right. Even if you have to use the addition method or any other method, just make sure that you've got that basic step done first and right, otherwise that knocks on with the rest of the work that we're doing here. Now, just like before, we have to start with the right-hand side of the sum. And again, there is history behind that, and I won't go into it just yet. Okay? So we add along these red lines that we've got here. Now here we've only got 8, so we're just going to write 8. Here we have 3, 1 and 6. Well, that gives us 10. So we write a 0 there, and we carry the 1. Just like we did in the column addition technique. We carry that over. We only want the units in each one, okay? So we've got 7, 6, 6, 1, 8. That's a lot of numbers to add up. 8 plus 1 is 9, plus 6 is 15, another 6 is 21, another 7 is 28, and don't forget that 1 at the bottom, 29. So we put the 9 there, and we carry that 2 over. 8 plus 5. The reason that we do that is because that's a 0, so we don't actually count that one, we can skip past that one. 8 plus 5 is 13, plus 4, 17, plus 2, 19, plus 2 is 21. 1 goes there, carry the 2. 2 plus 2 plus 2 plus 2, nice and easy, 8. And 1. So our answer is 18, 1, 9, 0, 8. 181,908. Only glad that we didn't use addition, multiplication by addition. So that's the Napiers grid. Remember, it's always important that you've got these diagonal lines set up right, and that's what makes this a lot faster than the traditional grid method. Both methods will give you the right answer, and you just have to pick which one you're most comfortable with. I hope this helps, and stay tuned for more.